To understand this natural phenomenon, we must first understand how a key component inside your car works. The spark plug, bear with me, is supplied with huge voltage from your car battery that is sent to the center electrode. However, there is a gap between the center electrode and the grounding tip. This forces the voltage to jump the gap. However, air is an insulator, you may be thinking, so how can it cross the gap? Well, the huge voltage ionizes the air, stripping the electrons from it, creating a path for the current to flow, and so the voltage jumps across, creating the spark. We will come back to this idea later. Storm clouds have huge updraft. This draws small water particles upwards from the bottom of the cloud to the top. While this happens, larger hail is too heavy at the top of the cloud, so falls down to the bottom. When this happens, water particles and hail interact, creating friction, causing electrons to be transferred to the water molecules. This process repeats, causing the top to become positively charged and the bottom to become negatively charged. This huge buildup of negative charge in the bottom attracts positive charges in the ground. Now that we've got this potential difference between the cloud and the ground, it acts very similarly to the spark plug, just on a larger scale. Step leaders seek out a path to the ground, as streamers reach from the ground upwards. When these meet, air is ionized, bridging the gap, allowing the voltage to rapidly discharge. So now we know how lightning works, but where does the thunder come from? Well, when discharge happens, all of the voltage is travelling along a 2 to 3 centimeter wide strip of ionized air. This small volume of air is exposed to a huge amount of voltage, which causes a massive heating effect. In fact, this air reaches 30,000 degrees C. That's 5 times hotter than the surface of the sun. This causes the heated air to rapidly expand, compressing the air around it. This makes a shock wave that we call thunder.